Good morning. My name is SAMBAVI THIRUVENKATARAJOO. I'm from Group 7. We would like to present about 5G antenna design, which is based on problem-based learning. My group members are MOHAMAD, KHILAL, AZIM bin Ali, MOHAMMAD NADZIRUL, ARIFF bin MOHAMMAD ZAID, and Magdalene Moses. Okay, 5G is the fifth generation mobile network, which is a new global wireless standard after 1G, 2G, 3G, and 4G network. 5G enables a new kind of network that is designed to connect virtually everyone and everything together, including machines, objects, and devices. 5G wireless technology is meant to deliver higher multi-Gbps peak, data speed, ultra-low latency, more reliability, massive network capacity, increased availability, and a more uniform user experience to more users. Higher performance and improve efficiency, empower new user experience, and connect new industries. Okay, our research specifically examines a well-engineered dipole antenna that is developed for microwave communication, running at a critical frequency of 2.4 gigahertz. As we explore the complexities in this antenna, it is crucial to acknowledge the crucial function antennas provide in enabling the transmission of information over the extensive network of 5G networks. These networks depend on several strategically positioned antennas to create a strong and integrated system, facilitating a smooth communication devices, networks, and wider Internet of Things ecosystem.
Propagation study, the microwave link. Frequency analysis concentrate on the 2.4 GHz frequency spectrum due to its optimal communication of data capacities and signal penetration. Examine the band capacity to overcome barriers and vulnerability to disruption, signal strength and path loss. Analyze the attenuation of signal strength, taking into account variables such as free space loss, as atmospheric absorption, and reflection. Comprehend the manner in which signal strength decreases as the distance increases in order to create network with the most effective coverage. The interference analysis evaluation probable source of interference such as electrical gadget or environmental condition. Examine methods to reduce interference and guarantee reliable and resistant communication. Multipath fading. Analyze the several time and amplitude of signal resulting from the presence of numerous signal. As for the antenna characteristic, we use the dipole antenna specification. It is as 1.4 until 6 GHz dipole omnidirectional with antenna, ground plane independent. The connector type is SMA, and antenna dimension is 8.2, 1.5, and 0.6, which is 207 times 38 and 15 millimeter. Antenna weight is 56 gram. Is operating under it can operate under temperature of minus 740 to 85. The environment is mostly indoor. The polarization is linear. The max input is 5 watt. Input and output is 5 watt. The frequency range is 1,400 until 2,700, 3,300 until 500 megahertz, 5,050 until 5,925 megahertz. It covers both LTE and 5G sub-6 bands from 1.4 until 6 gigahertz.
Now I will present about HFSS simulation for antenna design. So first, the design of dipole antenna is proposed in this section. Generally, a dipole antenna consists of two conductors which are half-wave dipole. The design antenna is to be surrounded with the airbox which is cylindrical in shape. The height and radius of the cylindrical airbox is 0.215 and 0.0775 mm. The design of the airbox is shown in the figure below. So, from the left top, which is airbox surrounded with airbox antenna, the purple one is airbox surrounded by dipole antenna, and the dipole antenna which is designed in bird shape The radius and height of the dipole is 1 mm and 122.8 mm. The dipole is created using the material called PEG. Uh, so next, for radiation pattern and gates, the dipole with the radiation falls to zero on the axis is perpendicular to the y-axis. The radiation pattern of 3D dipole is plotted approximately as a toric symmetric about the conductor in the half-wave dipole. If the antenna is mounted vertically, it will result in maximum radiation in horizontal direction. Next, for simulation result. The simulation result of the antenna are discussed below. The S parameter are used to identify the frequency loss, which is lowered down at 100 GHz. The 2D graph illustrating the S parameter value are shown in the figure. The impedance and reactance are opposite to each other, and the value of voltage V1 at frequency of 1 GHz.
Okay, for discussion part, we utilize a high-frequency structure simulator to model a dipole antenna, a popular type used in radio messaging, broadcast, and radar systems. The model, created either through the built-in wizard or manual definition, undergoes meshing for simulation. Material qualities and excitation details, including frequency and power, are specified. High-frequency structure simulator employs mathematical and numerical methods to solve electromagnetic equations. The simulation provides insights into antenna performance metrics like gain, directivity, and radiation patterns. High-frequency structure simulator enables quick design changes and assessment, considering nearby material that may impact antenna performance. Okay, for the conclusion part, designing and modeling a dipole antenna for the 2.4 GHz ISM band in the high-frequency structure simulator software is a challenging yet crucial task. The project aims to provide a hands-on experience in antenna design, optimizing dimensions for specific performance requirements. Simulation results will assess gain, return loss, radiation pattern, and directivity. High-frequency structure simulator streamlines the design process, allowing for precise evaluation and comparison with theoretical values. The software's potency extends to simulating antenna systems for various purposes, accounting for nearby objects and material that may impact functionality. Okay, that's all from us. Thank you.